What is question? So, okay. Now, another classification of a signal can be done on the values of the signal along the x-axis or along the time axis. Now, let's suppose this is the entire time axis. So, this time axis actually starts from minus infinity and it extends towards plus infinity. And this intersection between y and x is commonly referred to have a zero value. Now, if we want to look at the value of the signal in the positive time interval, so it is commonly referred to as the values of the signal, or the function is commonly referred to as x of t. So it is showing that we are considering the values of the signal at time which is positive. And if we want to consider the values of the signal in the negative values of time, then it is commonly referred to as x of minus t. So now keep this in mind and let us discuss an even signal. Now an even signal is actually that type of a signal which obeys the given condition, that is x of t is equal to x of minus t. What it means? It means that whatever are the values of the signal along the positive time axis, same values of the signal will be exhibited along the negative time axis. In other words, let's suppose if we have a signal that looks something like this. So along the positive time axis, a signal has a value of 1 at 0, and then a signal has a value of 0 at 0.1. So same values will be exhibited by this particular signal along the negative time axis. In other words, a signal is actually a signal along the positive time axis is actually a mirror image of the signal along the negative time axis. That is, both of these or values of the signal along the positive time will match exactly the values of the signal along the negative time interval. So such type of the signal, which is in fact a mirror image of itself, is commonly referred to as a even signal. So if you look at this particular signal, so it is actually a mirror image of itself. In other words, the values of the signal along the positive time axis are in fact equal to the values of the signal along the negative time axis. See, if you look at t is equal to 1, the value of the signal is 1. Similarly, at t is equal to minus 1, the value of the signal is 1. Similarly, at t is equal to 2, the value of the signal is here, it decreases to 0. Similarly, at t is equal to minus 2, so the value of the signal decreases to 0. So actually, the signal is actually a mirror image of itself, and the values of the signal along the positive time axis are same to the values of the signal along the negative time axis. Same goes for this particular signal, which is actually a cosine signal, which is extended in the positive and the negative time axis. So if you look at this particular point, so the value of the signal is 0 at minus pi by 2 and plus pi by 2. Similarly, the value of the signal is minus 1 at plus pi and minus pi. So this signal is actually a mirror image of itself. In other words, the values of the signal along the positive time axis are equal to the values of the signal or values of this particular function along the negative time axis. So such type of signals are commonly referred to as even signals. Now, another type of signals that are opposite to that of the even signals are commonly referred to as the odd signals. Now, previously we saw the value of the signal based on the basis of the time. Okay, this is t actually. So this represents the time in the signal. Now, if we multiply a minus with the function, so it means that a negative sign is multiplied, or you are multiplying a minus sign with the function. Let's suppose if we have a value of a signal that is 1, so in this particular case the value of a signal in over here will become minus 1. So what is the meaning of this? The meaning of this is that if a signal has a value of plus 1 at t is equal to, let's suppose at t is equal to 1, we will just call it at t is equal to 1. So the signal will have a value of minus 1 at t is equal to minus 1. In other words, a signal will have the values that are equal and opposite. In other words, the signal, if a signal has a value of 1 at x of t, so it will have a value of minus 1 at minus x of minus t. So the value of a signal is in fact equal and opposite. So what is an odd signal? So if you look at this particular figure, at t is equal to 1, the signal has a value of 1. However, at t is equal to minus 1, now the signal has a value of minus 1. So we can simply write that x of t is equal to minus x of t, minus x of minus t. Okay. For example, for t is equal to 1, the signal has a value of 1. Similarly, at t is equal to minus 1, the signal has a value of minus 1. Okay. This is at t is equal to 1. Similarly, if we look at the value, let's suppose if you look at the value at this particular point, so at this particular point at 1.5, the signal will have a value of 1. Similarly, at minus 1.5, the signal will have a value of minus 1. So this is actually the definition of an odd signal. That is, a signal is equal and opposite to itself. This is a simple sine wave which is extended along the x-axis and the negative x-axis, or the positive time and the negative time. So if you look at this particular point at pi by 2, the signal has a value of 1. However, when the time becomes negative, so the value of the signal will also become negative, and at minus pi by 2, now the signal has a value of minus 1. So an odd signal contains equal and opposite value along the positive and negative time axis. So as I previously mentioned, that an odd signals are actually those signals which contain equal values and opposite, and those values are opposite in nature. Let's suppose if we have a plus 1 along the positive time axis, so we will have a minus 1 along the negative time axis. If we have a plus 2 along the positive time axis, so we will have a minus 2 along the negative time axis. So odd signal contains equal and opposite values along the positive and negative time axis. So here this minus actually represents the nature of the time, that the time is negative, and this minus is actually representing the value of the function. That is, you are multiplying a minus 1 coefficient with your function, so it will actually makes your value equal and opposite to this particular function.